Hey everyone, and welcome back to Physics and Cosmos Academy.
It's your one-stop shop for all things mind-blowing in the world of physics.
We're going to break down the latest discoveries.
And make even the most complex concepts easy to grasp.
Exactly.
We're taking the intimidation factor out of physics.
Yeah.
And showing you just how exciting and relevant this field really is.
And today, we're diving into the fascinating world of neutrinos.
Now, you might be thinking, neutrinos? What are those?
Yeah, what are those?
Well, imagine tiny, almost massless particles that are constantly whizzing around us.
Okay.
Passing through everything, walls, planets, even you and me.
Wow.
Like ghostly little bullets.
Okay, that's a pretty wild image.
So these neutrinos are everywhere.
But if they're passing through us all the time, why haven't we noticed them?
That's because they rarely interact with matter.
Okay.
To put it into perspective, trillions of neutrinos are flying through your body every second.
Really?
And you'd never even know it.
So they're kind of like the ninjas of the particle world, stealthy and elusive?
Exactly. Okay. But even ninjas leave footprints sometimes, right?
Right.
And that's where scientists come in.
Uh-huh.
They've built incredibly sophisticated detectors to catch these fleeting particles in action.
And these detectors must be pretty impressive.
Oh, you bet they are.
If they're catching particles that barely interact with anything.
Think massive underground facilities like the IceCube Observatory in Antarctica.
Okay.
It's essentially a gigantic grid of sensors embedded in the ice,
Wow.
waiting patiently for a neutrino to finally bump into something and create a telltale signal.
So they're like cosmic detectives patiently gathering evidence of these elusive particles.
Yes.
And I bet when they do find one, it's a pretty big deal.
Oh, absolutely.
Especially when it's a neutrino unlike any we've ever seen before.
That's right.
Okay, you've got my attention.
What kind of neutrino are we talking about?
What kind?
Hold on to your hats, folks, because a brand new observatory called KM3NeT, submerged in the Mediterranean Sea, has just detected the highest energy neutrino ever recorded.
Whoa, highest energy ever.
We're calling it KM3 230213A.
Okay, I'm officially intrigued.
Just how powerful are we talking?
Yeah, paint me a picture.
Imagine the energy of particles smashing together inside the Large Hadron Collider,
Okay.
the most powerful particle accelerator on Earth.
Yeah.
Now, multiply that energy by 10,000.
Okay, my mind is officially blown.
It is mind-boggling, isn't it?
That's incomprehensible.
This neutrino is 30 times more energetic than any neutrino we've seen before.
Wow.
This discovery is a total game changer.
So how does KM3NeT even capture something this powerful?
Does it have a giant net down there or something? Oh, not quite a net,
Okay.
but it's an impressive setup nonetheless.
Okay.
Imagine long strings of what look like giant pearls strung deep underwater.
So I'm picturing these underwater strings of pearls.
Each pearl is a highly sensitive optical module
Okay.
designed to detect a very specific kind of light.
But how do they actually detect a neutrino?
They're looking for a faint blue flash called Cherenkov radiation.
Okay.
It's like a sonic boom.
A sonic boom.
But for light,
Wait, a sonic boom for light? How does that even work?
you see, nothing can travel faster than light in a vacuum.
Right.
But in water, light slows down a bit.
Okay.
When a particle like a neutrino zooms through the water faster than light can in that environment, it creates a shock wave of blue light that's Cherenkov radiation.
So it's like the particle is creating a mini light show as it speeds through the water.
Exactly.
Okay.
It's a beautiful and incredibly useful phenomenon because it allows us to detect particles that would otherwise be invisible.
Okay, that makes sense.
But how did scientists know that this blue flash was from our record-breaking neutrino KM3 230213A?
Yeah, how did they?
Well, on February 13th, 2023, KM3NeT picked up a very high-energy muon.
Okay.
And these muons can be created when neutrinos decay.
Okay.
Think of them like the neutrino's calling card.
Calling card. Okay.
The scientists were able to trace this particular muon back to the exact point where the neutrino interacted, creating that blue flash.
So they followed the muon's trail right back to the source like a cosmic breadcrumb trail.
Precisely.
Wow.
And by analyzing the muon's energy, which was at least 120 peta-electron volts, that's a huge E unit of energy, they knew the original neutrino had to be even more powerful.
Okay, I'm trying to wrap my head around this 120 peta-electron volts.
What does that even mean in terms we can understand?
Yeah.
Think of it this way. One peta-electron volt is about the same amount of energy as a flying mosquito.
Okay.
Now multiply that mosquito's energy by 120,
Okay.
and you start to get an idea of just how powerful this neutrino really was.
Okay, that puts it into perspective. This neutrino is basically the Mike Tyson of the particle world, a real heavy hitter.
Exactly.
But now the million-dollar question. Where did this ultra-high-energy neutrino come from?
That's a great question.
Given its insane energy level, I'm guessing it didn't just come from down the street.
You're absolutely right.
Okay.
This neutrino came from outside our galaxy, a cosmic traveler from a far, far away place.
Okay, now I'm really hooked.
In part 2, we'll dive into the potential cosmic origins of this incredible neutrino.
Make sure to stick around for that.
Welcome back to Physics and Cosmos Academy.
We're picking up right where we left off, folks, that mind-boggling ultra-high-energy neutrino detected by KM3NeT.
KM3 230213A, remember?
Right.
This tiny particle packed a punch 10,000 times greater than anything the Large Hadron Collider can produce.
It's truly remarkable.
And we left you hanging with some tantalizing possibilities about where it came from.
We did.
Right, so let's dig a little deeper into those potential sources.
Okay.
Shall we start with blazars?
Absolutely. Those supermassive black holes shooting out particle jets at nearly the speed of light.
It's like something out of a science fiction movie.
It really is.
It's pretty incredible, isn't it?
Yeah.
These blazars are among the most energetic phenomena in the universe.
Okay.
And when those jets are pointed directly at Earth, well, that's when things get really interesting.
So you're saying this neutrino might have been like a cosmic surfer riding one of those blazar waves?
Exactly. It's possible that KM3 230213A originated from a blazar far beyond our galaxy, hitched a ride on one of those powerful jets, and zipped its way to Earth.
Okay, that's pretty wild.
But what about the other possibility, those cosmic rays interacting with light from the Big Bang?
Right.
Yes, the cosmic microwave background.
Yeah.
It's like a faint echo of the universe's birth still permeating all of space.
And you said these high-energy cosmic rays can crash into those ancient photons and create neutrinos.
Precisely.
Okay.
And the resulting neutrinos could have extremely high energies, potentially even reaching the levels we see in KM3 230213A.
So this tiny particle might hold clues about both the most ancient events and the most energetic processes in the universe.
It's truly remarkable, isn't it?
It really is.
It's like a bridge connecting the very beginning of the cosmos to the powerful phenomena happening today.
Okay, I'm getting chills just thinking about it.
But we can't forget about the dark horse in this cosmic race, right?
Right, the dark horse.
Yes, dark matter.
Dark matter.
The mysterious substance that makes up about a quarter of the universe.
We can't see it or directly detect it, but we know it's there because of its gravitational effects.
Exactly.
Okay.
And one of the leading hypotheses is that dark matter might decay, releasing energy in the form of neutrinos.
So our ultra-high-energy neutrino, KM3 230213A, could be a sign of dark matter decaying somewhere out in the vastness of space.
It's a tantalizing possibility, isn't it?
It is.
If confirmed, it would be a major breakthrough in our understanding of dark matter.
Okay, so we've got these three incredible scenarios: blazars, cosmic rays, interacting with the cosmic microwave background, and dark matter decay.
How do scientists even begin to narrow it down?
Yeah, that's what I want to know.
Well, it's like piecing together a cosmic puzzle.
Okay.
They'll be looking for additional clues by studying the neutrino's direction energy and any other unique characteristics.
So it's like a cosmic forensic investigation.
Exactly.
Trying to figure out who'd do it.
They'll be comparing their findings to models and predictions to see which scenario best fits the data.
Right. And the location of KM3NeT in the Mediterranean Sea might play a key role in this investigation, right?
Absolutely.
Okay.
Its position gives it a unique vantage point to observe certain regions of the sky.
So it's like having a specialized telescope tuned to a specific channel of cosmic information.
Precisely.
Right.
And as KM3NeT continues to gather data, we might start to see patterns emerge,
Right.
helping us pinpoint the origin of these ultra-high-energy neutrinos.
It's amazing to think that these tiny elusive particles could hold the keys to unlocking some of the universe's greatest mysteries.
It's a testament to the power of scientific curiosity and ingenuity.
Yeah.
By studying the smallest of particles, we can glean insights into the grandest scales of the cosmos.
Well, this has been a truly mind-bending journey so far.
But we're not done yet, right?
Not done yet.
There's one more fascinating aspect to this story that we need to explore.
Oh, I can't wait.
Remember how we mentioned that KM3NeT detected this ultra-high energy neutrino before IceCube, which is a much larger observatory?
Yeah, that was a real head-scratcher.
Well, this unexpected discovery has sparked a debate about the sensitivity of different neutrino detectors
Okay.
and the role of chance in scientific breakthroughs.
Ooh, a cosmic rivalry.
Well, not exactly a rivalry,
Okay.
but it does highlight the importance of having multiple perspectives and approaches in science,
So it's like having different sets of eyes looking at the same cosmic event.
each one bringing its own strengths and limitations.
Yeah.
And sometimes the underdog can make groundbreaking discoveries simply because of its unique position
Uh-huh.
or a bit of serendipity.
It's a reminder that science is full of surprises and that we're constantly learning and refining our understanding of the universe.
Absolutely.
Okay, so what are some of the key differences between KM3NeT and IceCube that might have contributed to this outcome?
Well, for starters, their locations are vastly different.
Okay.
KM3NeT is submerged in the clear waters of the Mediterranean Sea.
And IceCube is buried deep within the ice of Antarctica, right?
Exactly. And those different environments can have a significant impact on the types of neutrinos each detector can observe.
So it's like each observatory has its own cosmic blind spots and sweet spots.
Precisely.
Okay.
The Mediterranean Sea offers a relatively clear view of the southern hemisphere sky.
Which is where KM3 230213A originated, right?
Exactly.
Okay.
And while IceCube has a wider field of view,
Yeah.
it might be more sensitive to neutrinos coming from other directions.
So it's possible that KM3NeT simply happened to be in the right place at the right time to catch this particular neutrino.
It's certainly a possibility.
Okay.
And that brings us to the role of chance in scientific discovery.
Ah, the serendipity factor.
Sometimes it's not just about having the biggest and best equipment, but also being in the right place at the right time.
Exactly.
Science is full of unexpected discoveries that happen when researchers stumble upon something they weren't even looking for.
It's a reminder that we should always be open to the unexpected and embrace the unknown.
And that curiosity and serendipity can often lead to the most groundbreaking breakthroughs.
Well, this has been an incredibly illuminating discussion about KM3 230213A and the role of different neutrino observatories in unraveling the mysteries of the universe.
But there's still one more piece of the puzzle we need to explore. Stay tuned for part 3, where we'll delve into the implications of this discovery for our understanding of the cosmos.
Don't go anywhere, folks. We'll be back soon to wrap things up with some mind-blowing insights from the Physics and Cosmos Academy. Welcome back to Physics and Cosmos Academy for the grand finale of our neutrino adventure.
We've journeyed through the subatomic world,
We have.
explored the mind-boggling energy of KM3 230213A,
Yeah.
and now it's time to answer the big question.
You get it. What does this discovery actually mean for our understanding of the universe?
Well, for starters, it confirms that the universe is an even wilder and more energetic place than we ever imagined.
I mean, we already knew about supermassive black holes and exploding stars.
Yeah.
But this neutrino takes it to a whole new level.
Absolutely.
Right.
KM3 230213A is basically telling us, hey, there are things out there that can generate energies far beyond anything you've ever seen or even dreamt of.
Wow, it's like the universe is showing off its power.
Precisely.
Yeah.
And this has huge implications for our understanding of cosmic accelerators like those Blazars we talked about.
Right, those supermassive black holes shooting out jets of particles at nearly the speed of light.
Exactly.
Yeah.
We used to think we had a pretty good grasp on how powerful those jets could be.
Uh-huh.
But this neutrino suggests we might have underestimated them.
So it's back to the drawing board for the astrophysicists.
In a way, yes.
Okay.
They'll be re-examining their models,
Right.
trying to figure out how these objects can produce such extreme energies.
It's exciting to think that this one tiny particle is forcing us to rethink some of our fundamental assumptions about the universe.
That's the beauty of science.
Yeah.
It's a constant process of discovery and revision.
And this neutrino isn't just challenging our existing theories, it's also opening up entirely new avenues of exploration.
Remember how we talked about neutrinos being like cosmic messengers?
Yeah, because they travel in straight lines,
Right.
unhindered by magnetic fields or dust clouds.
Exactly.
It's like having a direct line of sight to these incredible events.
They offer a unique window into the most extreme and violent processes in the universe.
Okay.
Processes that would otherwise be hidden from our view.
It's like having a backstage pass to the most exclusive cosmic show in town.
And one of the biggest mysteries we hope to solve with these ultra-high energy neutrinos is the origin of cosmic rays.
Oh, right, those charged particles that constantly bombard Earth from space.
Precisely.
Yeah.
We've known about cosmic rays for over a century,
Right.
but we still don't know for sure where they come from.
And why is that?
Well, because cosmic rays are charged particles. Their paths get bent and twisted by magnetic fields as they travel through space.
So it's like trying to trace a winding road back to its starting point after a blizzard has covered everything in snow.
A great analogy. But neutrinos, they travel in straight lines unaffected by those magnetic fields.
Right, so if we can find sources that emit both cosmic rays and neutrinos,
Yes.
we can finally connect the dots and solve this century-old mystery.
It's like having a cosmic GPS guiding us to the source of these enigmatic particles.
Amazing. And don't forget about the possibility that this neutrino could be linked to dark matter.
Ah, yes, the invisible substance that makes up about a quarter of the universe.
Right. We can't see it or directly detect it, but we know it's there because of its gravitational effects.
And one of the leading theories is that dark matter might decay, releasing energy in the form of neutrinos.
So if KM3 230213A was indeed produced by dark matter decay, it would be a monumental discovery.
It would revolutionize our understanding of this elusive substance
Yeah.
and potentially unlock some of the deepest secrets of the cosmos.
It's mind-boggling to think that this tiny particle could hold the key to understanding one of the biggest mysteries in the universe.
And that's what makes this discovery so exhilarating.
Yeah.
We're on the verge of a new era of cosmic exploration with neutrinos leading the way.
And who knows what other groundbreaking discoveries await us out there.
The universe is full of surprises, and I, for one, can't wait to see what we uncover next.
Well, that's it for our deep dive into the world of ultra-high energy neutrinos. We've covered a lot of ground,
We have.
from the basics of these elusive particles to their mind-blowing implications for our understanding of the cosmos.
We hope you've enjoyed the journey as much as we have.
If you're as fascinated by the universe as we are, don't forget to like and subscribe to Physics and Cosmos Academy for more mind-blowing explorations.
Until next time, keep looking up and never stop questioning the mysteries of the cosmos.